Good morning, everybody. I remain SIR-MuCOT Timothy. In this video, I'll be talking about logarithm, and this video is going to be as short as possible. So, without wasting much of our time, we start with log. The definition. What is logarithm? We'll define a logarithm by some alphabets. So now if they say the log of a number, let's say c to the base b to the base a is equals to what? B. This implies that when you raise a to the power b, you get back your what? C. This will give you back your c. So the log of a number c to the base a is b, which when you raise a to the number b, you get your number c. Take for instance 1024, which is what? 2 raised to the power 10. Now, if this is this, and this here is this, and this here is this, we put it in the form of log, which will now give us that log to the base 2 of 1024 is equal to what? 10. Because when you raise 2 to the power 10, you have what? 1024. Now let's take 1000 or maybe 10,000, which is equal to 10 to the power what? 4. This is what? Log to the base 10 of what? 10,000 is what? 4. Because when you raise 10 to the power 4, you have what? 10,000. And there are many examples of that. So that is some of the things I can tell you about logarithm. I'll go back to something much interesting. Which are the laws of logarithm. We'll go with the first one. There are many laws of logarithm. There are about 14, 13 to 15 of them. So the first one says that the log of a number, let's say a, the log of base axy is equal to what? Log base ax plus log base ay. Now we are asked to prove this. The proof of the first formula. Okay, so what we're going to do now is we use definition and prove it first. Using definition, we know that log to the base 10 of 1000 is equal to what? 3, because when you raise 10 to the power 3, you get back your 1000. So now I will not say log axy is equal to log ax plus log ay. Now when you raise this a to this, when you say when you say a raised to the power log ax plus log ay is equal to what? Xy. Let us check if the left hand side is equal to the right hand side. We will now say that this is a, right? Log ax, log ay. I can try to put this, I can say put log ax to be equals to m, log ay to be equals to n. I will now have that what I have here is log m plus n is equals to xy. Now remember the law of indices. When it is like this, it means that some multiplication that went on before, there's some multiplication like a raised to the power m multiplied by a raised to the power n, because they are the same base. That is why we got this one. It's equals to x, what? Y. You can now say put a raised to the power m equal to x and a raised to the power n equal to what? Y. This is y. Now you can now see that x multiplied by y is equal to what? X multiplied by y, xy is equal to xy. So that is the first. That is using definition of logarithm. Let's take another method, method 2. we can call this met 1. So I will not say that log of a number, log to the base ax y is equals to log to the base ax plus log to the base a y. Now remember, log to the base 10, 1000 is equals to what? Is equals to 3. I want to put this in the form of this one. 10 to the power 3 is equals to 1000. I want to put it in this form. I want to put this in this form. So putting it in that form, I have that log axy, log axy, let me call it z, or let me call it z, then log ax, I call it m, log ay, I call it n. So now this what I'll be working with, log axy equal to z, log ax equals to m, log ay equals to n. So now I'll now say, since my log ax is equals to m and log ay is equals to n, but my log axy is equal to what? Z. Now I'm not going to change this. I'm not going to say that my z is equal to what? My z, okay, my a raised to the power z is equal to what? X, y. My a raised to the power z is equal to what? X, y. Now let's check. This is what I have. Man, it's equal to x, y. Okay. From here, I know that log ax is equal to what? My log ax is what? Log ax is what? M, meaning that this follows that a raised to the power m is equal to what? X, and log ay is equal to what? N, and it follows that a raised to the power n is equal to what? Y. So this is my x and this is my y. So my y is what? So a raised to the power z is equal to my x is what? My x is a raised to the power m. Yes. My x is what? A raised to the power m multiplied by my y is what? A raised to the power n. And I'll say that a raised to the power z is equal to a raised to the power m multiplied by what? A raised to the power n. Remember, in indices, when they have the same base, you just add the powers. A raised to the power z is equal to a raised to the power what? M plus n. Since they have the same base, you can just equate the index, which is z is equal to what? M plus n. And what is your z? Your z is what? Your log x, your z is equal to log ax what? Y. Your m is equal to what? Log ax, and your n is equal to log ay. So this implies that your log axy is equal to your log ax plus your log ay. So now I tried many other things. Many other things. I tried to use this a raised to power m multiplied by a raised to power n to be equal to a m plus n, and I tried using a raised to power m multiplied by b raised to power m to be equal to a multiplied by b raised to power m. I tried to use these two like this, but it gave me tough time, but I'll still check if I can do them. So far so good. This is where I wish to stop. In my subsequent video, videos, I will complete the proof of the law of logarithm. Thank you. Do have a nice day. I remain Olisa Chukwuebuka Timothy.